Example 1 says the liquid portion of a diet is to provide at least 300 calories, 36 units of vitamin A, and 90 units of vitamin C daily. A cup of dietary drink X costs 12 cents and provides 60 calories, 12 units of vitamin A, 10 units of vitamin C. A cup of dietary drink Y costs 15 cents and provides 60 calories, 6 units of vitamin A, and 30 units of vitamin C. How many cups of each drink should be consumed each day to minimize the cost and still meet the daily requirements? As we start these problems, the first thing you want to know is the variable. And it's very important that you understand what the variable is because it's going to help you determine your constraints later on. So right here it says how many cups of each drink. So we're looking at the two different types of drinks that we have. We have drink X and we have drink Y. So we're going to let X equal the number of cups of drink X, and we'll let Y equal the number of cups of drink Y. Then what we have to do is we have to come up with what we call the objective function. So what is our goal here? And our goal here is to minimize the cost. So our objective function is dealing with the cost of drink X and drink Y. We'll start with Z equals, and we'll do that every time for our objective function. Z is going to equal something. And again, in this term, we're talking about the cost of our cups of drink X and drink Y. So if we look through our problem, we need to know the cost. So a cup of dietary drink X costs 12 cents, and drink Y costs 15 cents. So we can write this as 0.12 times X plus 0.15 times Y. And that's our objective function. Then what we have to do is we have to write down our constraints. So the first two constraints that we should be aware of and remember is that if we're talking about a number of cups of drink, we're not going to have anything that's less than 0. So our first two constraints would be X is greater than or equal to 0, and we also want to note that Y has to be greater than or equal to 0. Then we're talking about three different things in this problem as we're comparing our drinks. The diet that we have has to have 300 calories, 36 vitamin A units, and 90 units of vitamin C. So each of these different drinks has a different amount of those calories, vitamin A, and vitamin C. So we're going to make a separate inequality for each one of those. So we're going to make one inequality having to do with calories. And if we take a look at the calories, it says drink X has 60 calories and drink Y also has 60 calories. And the diet altogether has to have at least 300 calories, which means it has to have 300 calories or more. So our inequality would be 60x plus 60y is greater than or equal to 300. Then we have to go ahead and look at vitamin A, which is our other thing that we're talking about here. And if we look at the vitamin A, altogether we need at least 36 units of vitamin A. Drink X has 12 units, and drink Y has 6 units. So we can write that inequality as 12X plus 6Y has to be greater than or equal to 36. And then the other thing we're talking about here is vitamin C. So vitamin C, we need 90 units of vitamin C altogether, or at least 90 units. And then drink X has 10 units of vitamin C, and drink Y has 30 units of vitamin C. So our inequality would be 10X plus 30Y is greater than or equal to 90. Now, once we have our objective functions and our constraints, everything else is like we've done before. So the only new thing that we're doing today is coming up with all this information on our own having to do with an actual word problem. So now what we do is we have to go through and graph those constraints. So we'll do that here. The first one that we have is x is greater than or equal to 0. So that's going to be my vertical line. So I'm going to go ahead and graph that in here. Again, you should have straight lines. So use a straight edge. Get your lines as straight as possible. Use an ID if you need to. My lines I'm going to do the best that I can, but yours should be a lot more accurate than mine. Y is greater than or equal to 0. That's just a horizontal line here. And then we have to graph our other ones. So let's start with our calories. So we have 60x plus 60y is greater than or equal to 300. I'm going to start by subtracting that 60x over to the other side. So I'm looking at 60y is greater than or equal to 300 minus 60x. Dividing everything by 60, I get y is greater than or equal to 5 minus x. So let's graph that. I have a y-intercept of 5, so I'm going to start at my y-intercept here. And my slope is -1, telling me that I can go down 1 and to the right 1. And I'm going to make as many points as I can on here, just in case I need those for the intersection point. All right, then I'm going to go ahead to my vitamin A line, my purple one. I'm going to start by subtracting that 12x over to the other side. So I have 6y is greater than or equal to 36 minus 12x. And then I'm dividing everything by 6. So y is greater than or equal to 6 minus 2x. If I graph that, I have a y-intercept of 6. And then I'm going down 2 and to the right 1. And then draw on your straight line. And then my orange line, my vitamin C, I'll start by subtracting the 10x over to the other side. I get 30y is greater than or equal to 90 minus 10x. And then if I divide everything by 30, I get y is greater than or equal to 3 minus 1/3 x. So here I have a y-intercept of 3. And I'm going down 1 and to the right 3. And then again, try to get your line as straight as possible. And then I have to think about my shaded region. So if I take a look at all my lines, all of these have to be greater than or equal to. So that means I am above every line. So I need to shade everything in this above category. So I'm everything up here. My next step then is to find my vertices. So let's move this up. Let's take a look at my graph, and we're going to find those vertices and we're going to plug them into our objective function. As we move along, we're looking for the intersection, anything that intersects around our shaded region. So the first point that we get to that's intersecting is the purple line and the gray line, which is the point 0.6. So one of my intersection points is the point 0.6. Then if I continue along, so I get to the intersection of the purple and the red line. And if your lines are really straight, you should see that they do intersect at a very nice point here, which is the point 1,4. So I also have the point 1,4. Then as I continue along, so here I am, I'm going to go this way, and I get the intersection of the yellow and the red line. And that again is a very nice point, since I know for sure they cross there. That's the point 3,2. So I know I have the point 3,2. And then as I continue along here, I get to the intersection of the orange and the brown line, which intersect at the point 9,0. Then what I need to do is I need to plug these into my objective function. So my objective function, if you forgot, I'm going to write it up here, was z equals 0.12x plus 0.15y. So let's do that. So if I plug this one in, I get 0.12 times 0 plus 0.15 times 6. and that is going to be equal to 0.9. If I plug the next one in, 0.12 times 1 plus 0.15 times 4, that will give me 0.72. Plugging in 3, 2, I get 0.12 times 3 plus 0.15 times 2, and that will give me 0.66. And if I plug in 9, 0, I get 0.12 times 9 plus 0.15 times 0, and that's equal to 1.08. Then what I want to do is I want to know what is the minimum cost and when does it exist. So if I go and look at all these values here, I want to find out which one is the minimum. So which one is the smallest one? And if I look for that smallest one, I can see that it's this right here. 0.66 is the smallest number from all of these. So I can say the minimum cost is 66 cents per day, and it occurs, oops, let's erase that. Whoops. So it occurs when 3 cups of drink X are consumed and 2 cups of drink Y are consumed. If you have any questions, let me know.